Let's start the second lecture of Arduino and drone programming. We started the last lecture by studying different components, and we know that when we have to make the circuit for any electronic equipment, then we need to use different components, and those components are resistor, capacitor, inductor, etc. And those components we had studied in previous lecture. Going ahead, now we are going to talk about some more components. One of them is transistor. So let's start our today's session with transistor. Transistor, if you see this word, it is combination of two different words. First is trans and second is resistor. It means it offers three different type of resistances. Okay, about the resistances we have studied in previous lecture, so it is not a difficult thing. We know that what resistance is. Resistance is basically something which offers the restrictions in the flow of current. So now there are three different type of resistors available in this transistor. Let's see the definition of the transistor. A transistor is a semiconductor device used to amplify or switch electronic signals and electrical power. It is composed of semiconductor material, usually with terminals for connection to an external circuit. So we can see from here, a transistor is a semiconductor device or the component which is used to amplify or switch electronic signals. So if we talk about amplification or switching, we know that many of the times, like I'm speaking as right now, and the voice is reaching to you. It may happen that you are having some external noise and you are unable to listen to me. Then what you will do, you will raise the strength of the voice signal. So you will go to your computer or mobile phone, find the volume button, and you will increase the volume. And as you increase the volume will be audible to you. Now, have you ever think when you are increasing the volume at your end, am I started speaking loudly? No, the answer is no. I am in the same pitch as earlier. But what you are doing, as per your need, as per your requirement, you are increasing or decreasing the volume at your end. I am not changing anything from my end. So the sender is sending the same level of the signal, but at your level, you can increase or decrease the level of the same signal. Suppose I am speaking in a particular level of 30 units and you want the signal to be raised up to 70. Can you do it? The answer is yes. We can raise the strength of the signal, but to raise the strength of the signal or to increase the signal strength, we need to amplify the signal, and for that we need to use some amplifier circuits. Transistor is the core component of any amplification circuit. So you can understand that transistor is very useful. As and when we need to increase the strength of any particular signal, we can use the transistor. The second application of the transistor is as a switch. The switch is an electronic switch because it has three terminals. At a time, one particular terminal you can keep in on condition and another terminal you can keep as off condition by applying different type of polarities of the battery to the transistor. So that's why we can use it electronic switch, that we'll see later. Again, let's see how it functions. You can see the diagram, and here you can find that earlier the water is stopped by a stopper, the entire water. As more pressure will come to that stopper, the stopper will go away, and as the stopper will go away, the water starts flowing into other terminals. So here the terminals are named as basis, emitter, collector. All the water is available at the collector side. Later on, when these two stoppers are being removed, then the water starts flowing into emitter as well as the basis side. In the same principle, our transistor works. You can see the diagram at the bottom here, the smaller diagram. Okay, if you see this diagram, you will find that earlier the switch is off. When it gets open, the current starts flowing in the circuit. Okay, so this is the way how the transistor functions. Let us see the symbol of the transistor. As I told you, it offers three different type of resistances. That's why it is transistor, trans resistor. So these three different type of the resistances are, you can see in the second diagram at the bottom, it is written that NPN or PNP. What this NPN and PNP is? The NPN and PNP is actually the name convention of the transistor because of the materials used. The materials which are used. In previous lecture, we had seen the concept of diode, wherein we know that we can use P-type and N-type semiconductor materials to form a diode that is also called as PN junction diode. Okay, so there are two types of the semiconductors used to create the component diode, which was P-type and N-type. Now, the opposite side of the material, if we add to a diode, let us consider this diagram. This one, let me annotate. Yeah, here, let us consider this diagram. Here it is P-type and N-type. So this part is actually a diode. This much part is actually works as a diode. Now, if I will add the opposite semiconductor at either of the side, it means here we have N-type. So I can add the opposite of N-type semiconductor, that is P-type. So here we have added P-type. So from the beginning, if you will see, this is P-type, N-type and P again. So it will be considered as PNP. Okay, it is considered as PNP, and PNP forms a transistor. Similarly, suppose we have P here and N here. So here I want to add opposite type of semiconductor. So opposite type of semiconductor of P is N. So it will become NPN. Now, one more thing that you need to remember. If you see the symbol here, PNP and NPN, you can find the size of N, P, and then N, or elsewhere P, N, and then P is different. The sizes of the components are different. We are making them like this intentionally. Okay, the sizes of the components PNP and NPN are different, and it is made like this intentionally so that we can use the transistor as desired. You might also be having one question, why the maker or developer of the transistor has given the name PNP, NPN. In place of that, they could have given the name like Ramsham, Ghansham. So why they have given the name like PNP and NPN? So the reason behind that is it will be easy to remember to the word positive and negative. P stands for positive, N stands for negative. So it is not positive semiconductor or negative semiconductor. We are talking about some semiconductor which has holes as majority carrier and electrons as minority carrier. Now, in the extrinsic semiconductor, the semiconductors which are having holes as majority means more number of holes are available in that semiconductor, is having positivity, more positivity because holes are positive. And the semiconductor which are the trivalent semiconductors and having electrons as majority carrier are more negative. So that's why those type of semiconductor materials are considered as negative N-type semiconductor. Now, this is about the symbol of this transistor. So we have two types of transistor, PNP and NPN. Now, when we have two types of transistor, there we have three different connections. There we have three different connections, and those connections are named differently because they function differently. How they are named, why they are named, and how they function, this we need to understand. Accordingly, because there are two different type of the semiconductor, it is just like twin brothers or sister. So they should look also differently, or we should be able to find them. And accordingly, the electronic symbol which has been made are different for both the transistors. So as I told you that there are three different terminals. These terminals are named here: basis, emitter, collector. The words are coming from Greek words. In US English, we consider the basis as base. Okay. Emitter is kept similar, emitter, and the collector is considered as collector. Okay, COLLECTOR. Okay, so we have three different terminal EBC, emitter, base, collector. Now, the symbol, this is the symbol. This entire transistor is like a tanker. You can see here, the water is stored somewhere at the collector. So this entire transistor is represented by this circle. Okay, it represents the entire p type, n type, and again p type, so that we have represented electronically by a circle. Okay, and there are three terminals, base, emitter, and collector. So here the base, you can see, is the horizontal or the vertical line. So here the base is represented by always this vertical line is representing the base. It can be horizontal if we'll rotate it by 180 degree. You can imagine if I'll rotate this by 180 degree, it will become horizontal. So horizontal or vertical line, it is the middle thing. So that's why it is called as base. It is the middle thing from where the emitter and collector is connected. So that is, base is kept either vertical or horizontal. And then after, collector and emitter are connected to the base. So two inclined lines we have used, one for collector, one for emitter, one for collector, one for emitter. Now, both the lines are inclined. It will be very difficult for you to find which one is collector and which one is emitter. They both looks similar. So it is difficult for us. Base, we can easily find it out. Let's consider there are three students standing, and those three students, those who are standing in, they are standing in some sequence wherein first Ram, then Sham, then Ghansham. Okay, so we know that first Ram, then Sham. So Sham is a middleman, and then Ghansham. First is Ram, second is Sham, third is Ghansham. Okay, so that middleman can be easily called as base. Now one is first and one is last. The second, for the second, there is no issue. You can find ki second kaun hai. But one person is first and one person is last. Now, how to find who is first, who is last? If I'm seeing from north side, maybe Ram is first. If I'm seeing from south side, maybe Ghansham is first. Okay, so to avoid that confusion, the arrowhead is connected with the emitter. So always whenever you will find some arrowhead, that particular terminal of the transistor is considered as emitter. So you can see here with the emitter, the arrow, dark arrow is connected. Okay, so these things we easily make out. That transistor is a three-terminal device which has base, emitter, and collector. In the symbol, the size of each individual component, semiconductor, is different. Okay, the collector is always kept the larger, and then after the emitter, and the base is always very thin. This we can see from the diagram. Now in electronic symbol, the entire arrangement is kept as a circle. The base terminal is kept vertically or horizontally, and the emitter and collector is kept represented by inclined lines. Now, because both are inclined lines, it is very difficult to find which is emitter and which is collector. The arrow is connected, is available on the emitter terminal. Now, because there are two types of transistor, NPN and PNP, and both are having the similar symbol, it will be difficult which is NPN and which is PNP. It is difficult to find if the symbol will remain the same. So that's why again one differentiation is given. If you read any particular book, any book, I can give guarantee. If you read any book, you will not find this concept. Why the symbols are made in this way, why the arrowhead is applied, everything, there is some reason. ऐसा नहीं कि मन आया और डाल दिया. Okay, so now here NPN, अगर आप देखेंगे first वाला, the arrowhead is touching the circle, and if you find PNP, the arrowhead is touching the base. Why the hell they have done like this? कोई तो reason होगा. Now, the reason is when we make the circuit arrangement, when we apply the inputs and we take the output, it happens that if we are using NPN transistor, the current goes out from emitter, and when we connect PNP transistor, the current comes from emitter. Okay, keeping this logic in mind, the arrowhead is kept at different places. This is the electronic symbol, but how actually it appears, physical appearance is how. So the transistor is this. At the bottom, the new diagram has come. You can see here, and you can find here that there is emitter, base, and collector. So the middle one is collector. You can consider this, that the last one is base, and this one is emitter. Okay, now you will say, sir, emitter should be on the middle. Sorry, base should be on the middle. Why it is kept like that? So when you will find the physical transistor, then that time you will understand that the base is how they have kept. Okay, it is now looking in different way because it is the 3D diagram, but always it is kept on the middle. Okay, so don't get confused. The circuit arrangement, as I told you about the transistor, that the transistor is made up of three different semiconductors, NPN and PNP. I have taken here in the diagram NPN transistor, and I am showing you how it functions. Now, when we connect transistor, there are two different ways through which we can connect, three different ways through which we can connect the transistors, and those ways are called as biasing, B-I-A-S-I-N-G, biasing. Okay, and that biasing technique is common base connection, common emitter connection, and common collector connection. Okay, in common base connection, the base is common for emitter and collector. In common emitter connection, emitter is common for base and collector. In common collector connection, collector is common for base and emitter. Okay, so here this is base. You can see here this is base. It is connected. This is emitter. Now this base is connected to emitter. So this particular part is base emitter or emitter base. This part I am continuously rotating my mouse. You can see from here, this particular part is base emitter part. Now the second, you can see the emitter is also connected to collector. The emitter is also connected to the collector. So here it is emitter collector connection for the two connections. Okay, so similarly we can have common collector and common base, and in this way the circuit is arranged. Normally there are two terminals and we kept the input. This is your input terminal. Okay, this is your input terminal. So in input terminal, one terminal is kept in forward bias, another is kept in reverse bias. So P type is connected to positive terminal of the battery and N type is connected to negative terminal of the battery. Here also, if you'll see, these are two N type semiconductors, so there won't be any positive or negative terminal side. So emitter, because here emitter is connected to negative, so here also emitter will be connected to negative, and the other terminal will be connected to positive terminal of the battery. So this is to operate the transistor, this circuit arrangement we need to make in terms of common base, common emitter, or common collector connection. I know it is very quite difficult because I have taught you in last 15 to 10 minutes. I have taught you around 6 different topics of the transistor. It is very large, very huge topic, and in a short span of time I had taught you only to tell you that there is a component which is called as transistor. There are 3 different connections that we can have: common base, common emitter, common collector. There are 3 different terminals: base, emitter, and connection. And transistor is used to amplify or to switch the signal as an amplifier or as a switch. Okay, so let's move further. The next device component that we are talking about is the potentiometer. Potentiometer. Now the potentiometer is nothing but, it is not a meter. Okay, don't be confused that it should be a meter like voltmeter, a meter. It is not like that. The potentiometers are variable resistors. In plain English, they have some sort of knob or slider that you turn or push to change resistance in a circuit. If you have ever used a volume knob or a stereo or a sliding dimmer, then you have used potentiometer. The concept is very simple. In other words, if I'll say, if ever you have used if ever you have used the switch which increases or decreases the speed of your fan, ceiling fan, then you have used potentiometer. Okay. Nowadays, there is a small voltage regulator comes that in our fans, rounded knob that you need to rotate. And accordingly, the speed of the fan increases or decreases. That is a type of potentiometer. Or then you have the regulator like tuck, 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 1, 2, 3, 4, 5 like that. That is also a type of potentiometer. Okay. What exactly it does? When we offer the resistance, the resistance restricts the current flow in any of the circuit. When we offer the resistance restricts the flow of current in any of the circuit. This is a well-known fact. The condition is when we offer higher resistance, we get less current. When we offer lesser resistance, we get high amount of current. Now, this is the common knowing that we all are aware. So this particular concept is used to variate the resistance of any circuit so that the amount of the current that is reaching to the circuit can variate. And when the input signal variates, your device will also give you the variated output. It means if more amount of current will be given to a fan, it will speed in high RPM. If the less amount of the current will be given to your fan, it will rotate in lesser RPM. So the circuit can be operated in different way. And that's why we are using this equipment, potentiometer, which has the capacity by sliding or by rotating, we can change the resistance of the circuit. Similar type of the concept is also used in the old radios. You might have seen the old radios wherein there was a scale on which some numbers had been written, and then there was a knob that we rotate, and accordingly one stick which was above that scale rotates, and we can see that the radio signal is changing. That also works in similar way. So let's see the diagram. These type of things are called as potentiometer. How it works? You can see from here, as you are rotating, the light bulb LED is dimming or working in full bright condition. Okay. And this is only the function. And how exactly it works? Like this. You can see at the bottom, the resistance, variable resistance is varying. Lesser resistance, more light. Higher resistance, less light. Yeah, let's move ahead. So if anyone is having any doubt till now, you can now unmute yourself. I've opened the thing. So if you want, you can unmute right now if have any doubt. Okay, so I don't think there is any doubt. If anyone is having any doubt, you can write your question on chat box. I'll answer to your question. Now, coming next, LEDs. We all are aware with LED word because we all might be using LED TVs, and that LED and this LED is same. But here what LED we are going to talk about is bigger in size and not in the form of pixels. And the LED TV that you are having at your home is very smaller size LEDs you have there. Okay, you cannot differentiate between the two LEDs. In that way, it is smaller like that. LED is what? LED is basically light emitting diode. It is also a diode. Diode we have seen previously, PN junction diode. Then in transistor we studied P-type, N-type. Now here also again diode. So LED is light emitting diode. It is a diode. Okay. It is basically a special type of diode which emits the current from its surface when the external energy is applied. When you apply the external energy, then it emits the current. Again, I am telling you, LED emits the current from its surface when we are electrically charging the LEDs. Okay, let's read the definition. LED stands for light emitting diode. It is basically a special type of diode that lights up when electricity passes through it. Like all diodes, the LED is polarized and electricity is only intended to pass through in one direction. Okay, let's see how it appears. So this is the LED. LED comes in different colors. You might have seen during the Diwali, or now the Christmas is coming. So for decoration, we are using LED lights, and that comes with different color because of the semiconductor material used to make that PN junction. Different semiconductor of P type and N type generates different type of current. Okay, so here the outer to protect the inside circuit, and to give you the light like a bulb, we have coated that with transparent plastic so that we can secure the circuit with external humidity and moisture and other things. Otherwise, LED always not like that. Okay, so that is the outer coating, the transparent plastic that you can see over the LED is only to protect that, and then your LED appears like a small bulb. Otherwise, that is of no use. Actual circuit is inside. You can see here, this part. Okay, one is called as P type and one is N type, and then it emits the current from this surface, this much part. So here the LED is having cathode, which is negative terminal, and anode, which is positive terminal. Always how to find which is negative and which is positive, and for that the LED is made in such a way that one leg of the LED is smaller than other leg. Okay, and then accordingly you can find smaller leg is cathode and the larger leg is anode. This is how the LED functions. Intentionally, I have kept the LED which is giving you two colors, red and yellow, because inside that outer coating there are two LEDs available which are made in such a way that the first LED, the terminals LED and anode and cathode is single, but they are made in such a way that first this LED is working, first LED, and then after the current is going to the second LED, and then accordingly it is changing. It look like it is changing the color. How it electronically functions like this. This is positive, means P type, negative means N type. The P type terminal is connected to positive terminal of the battery, and N type terminal is connected to negative terminal of the battery. Okay, so from here the positive, so positive holes repels, here negative, so negative electrons will repel from here, so they will try to move towards positive terminal, the electrons, and the holes will try to move towards the negative terminal. They travel, and when they collide, few can pass, but few are colliding with each other, then the light comes out. Okay, so this is about the LED. Moving ahead, switch. We have talked about the switch. Diode can be used as a switch, as well as transistor can be used as a switch. What exactly is the switch? We use all these components in our circuit. A switch is basically a mechanical device that creates a break in a circuit. When you activate the switch, it opens and closes the circuit. Always remember, this is the electronic symbol of switch, and different type of switches available in the market. So now when the switch is like this, it is not connected, this part is not connected over here, the switch is called as opened switch. Yeah, open switch. Okay, and whenever any particular switch is open, it is not connected, then the current cannot flow, because we know that in open circuit no current flows. So your fan or bulb or anything, whatever you are keeping, that will be in off condition. When it changes, it goes down, the switch will be in on, the circuit will be in closed condition. Okay, so now you can see here in this diagram, ये घर पे आप रोज करते हो लाइट को बंद और चालू, same thing is happening here. And a different type of the switches available in the market. There are push button switch, there are sliding switch, there are rotating switch, etc, etc. Like you might have seen, the switch that you're using to start your tube light or bulb or TV, that switch mechanically you need to operate. Okay, you need to physically press that switch and then works. At the same time, when you use the bell switch, you might be having the bell at your home. So when you're pressing, it automatically returns to its old position. So there are, the switch looks the similar, but the functioning is different. There is a spring that that keeps, you need to press. So when you press, give the physical energy from external side, you press, the spring will go down, and then after for some particular time, the switch will get enabled and the current will flow in the bell, and then accordingly it rings. And when you start pushing that, stop pushing that, because of the spring, it will go to its older position, and the circuit will deactivates, and then the bell will stop. So different type of switches, but all these switches are the physical switches. Okay, electronics, in electronics there are electronic switches which turns automatically. Here, to turn on or to turn off, we have to do it physically. But there are electronic switches which automatically turns on or turns off. Those type of switches are called as electronic switch, and diode and transistor is one example of that. Using the diode and transistor, we can make the electronic switch. Let's move forward. Breadboard. When you practically do the experiments later on, you are going to use this breadboard. The breadboard looks like a bread, not exactly like a bread, but you might have seen, you all have seen the bread, and you have observed that small holes are there on the surface of the bread. So here also on the breadboard, you will find smaller holes like this. These breadboards are used to create the circuit temporarily. Temporarily, if you need to create the circuit, then we are using the breadboard, because the circuits are made permanent by using the PCB. PCB stands for printed circuit board. Okay, PCB stands for printed circuit board. And if suppose you are making any circuit and directly you will use PCB, printed circuit board, it is permanent. So you need to create, if there is any mistake on your circuit, that board cannot be used again. So that's why in experiments, we use the PCBs, printed circuit boards, and these printed circuit boards, you can easily, if you have made any mistake, you can easily change the circuit and you can rearrange the circuit. Okay, so let's talk about the breadboard. Breadboards are special boards for prototyping electronics. Prototyping means for making the circuit, testing purpose. And then when you are making the basic circuit and you need to test, you can use the breadboard. They are covered with a grid of holes which are split into electrically continuous rows. In the central part, there are two columns of rows that are side by side. This is designed to allow you to be able to insert the integrated circuits into the center. After it is inserted, each pin of the integrated circuit will have a row of electronically continuous holes connected to it. Let me explain it, because I know that sometimes it is difficult to understand and read. So here you can see this diagram, this breadboard you can see. It is separated by color lines. It is not necessary that always you will get the separated by color lines. Blue and red color are being used here. Maybe you will find something with red and orange color, or maybe some other colors. Okay, and some numbers are written over here. Not necessarily that in all the breadboards you will find the numbers written. Okay, now if you will see, any breadboard is like this. A complete breadboard is like this. The size can be anything. Top, this is the top. which is separated by blue and horizontally blue. Yeah, you can see vertically also, you can see say horizontally or vertically here, first and last. So top and bottom separated line, there are two lines only, two holes only, two rows only. There are two rows only. Here you can see. Okay. So top and then bottom also two rows. These are internally horizontally connected. These are internally horizontally connected. What does it mean? It means that if you apply some amount of voltage or current over here, because it is horizontally connected, if you are applying something here, let me annotate again. If you are applying something here, the same amount of the value you will get from here, or any other place. So the same voltage will be applied throughout the circuit here horizontally like this. Okay. Now, if you're applying something here, then the same amount you will get over here. But if you apply here on the first row, and if you want to take the same output from the second row, it is not practically possible because it is not vertically connected. Similarly, at the bottom, the top and bottom is horizontally connected. The middle part, this to this, yahan se yahan tak, they are vertically connected. And you can see 6 holes in each and then separated by a middle layer. This is the middle layer. Okay. So if you need to connect any IC, that is called as integrated circuit, you connect the integrated circuit between this, like this. You can connect the integrated circuit. Okay. In between, you cannot put here or here the entire IC. You have to keep like this. The size is made in such a way, whether you are using the smallest breadboard or the largest breadboard, you can keep like this. Okay. Now, these pins are vertically connected. It means if you apply some voltage here, the same you will get from here. These are vertically connected. Similarly, these are vertically connected, but there is no internal connection between this separated part to this separated part. Okay. So this is breadboard. You need to understand the concept used. Again, I am repeating the same thing. The top and the bottom two lines are horizontally connected. The middle part is separated again into two parts. So upper part and lower middle part, upper middle part and lower middle part, they are separated with each other and they are vertically connected. Next, when we are using the breadboard are having the holes. We cannot use simple wires because they are not having that much strength so that we can push it and insert it inside the hole. So that's why we need to use the jumper wires. Okay. These type of jumper wires normally we are using, and you can see here the end terminals are having some steel body and through which we can insert it. Now the AC power source. We need to give power to every electronic or electrical instrument so that it can work. We know that there are two types of power available. One is AC power, another is DC power. We can convert the AC power to DC power. We need to use some power sources. A power source is a source of power. It means it is a source from which you can apply electrical energy to any particular device. Just like the socket that you can see right now at your home, in your room, there is a socket where we can connect the plug and we can charge our mobile phones. That is the power source, and that provides you AC power like this. When the switch is on condition, you will get the power. The AC signal that we are using is continuous in nature and having two sides, positive and negative. And having the higher strength, 220 volt that we are getting at our home. But our electronic instrument work at lower voltage, not at 220 volts. It works at some lower voltage. If you connect your electronic instruments directly to the 220 volt power supply, it will not work. So if you apply 220 volt directly to your device, electronic component, it will burst because their power requirement is 3 to 5 volt. Just like human beings. Okay, we can have 3 or 4 chapatis, but small children at the age of 3 or 2 cannot have 3 or 4 chapatis. One is enough for him or her. Similarly, the semiconductor material cannot bear more amount of the voltage. So that's why we need to apply lesser amount of voltage. The second thing is the AC is alternating, but the semiconductor material requires DC current. So we need to convert the alternating current into direct current, and for that we are using the rectifier circuit. Rectifier is a circuit which converts alternating current into direct current. You can see this is alternating current which has the positive half as well as the negative half, and this input signal is converted into the DC output which has only positive half. Here you can see the output diagram. Okay, now how the circuit functions: we are using diode and we are applying positive terminal of the diode to the positive terminal of AC signal and negative terminal of the diode to the negative terminal of the AC signal. Okay, so in forward bias, the diode works and it allows the current to flow through it. In reverse bias, it will not work and will not allow the current to flow through it. This is the general concept of diode. So here when we are applying the AC signal, during this V in positive, the upper half of the AC sinusoidal signal, the diode will become in forward bias and the current can flow. When it comes downwards, okay, the diode will become in reverse bias, and during the reverse bias, it will now not allow the current to flow through it. So we are getting the output only for the positive half and the negative half is suppressed. This is half wave. Similarly, we have center tap full wave rectifier, wherein in this arrangement, we are using two diodes connected in the similar fashion, just like forward biasing and reverse biasing. So during the positive half, the diode D1 will be in forward bias. So it will work and it will give you the output from here to here. At the output, I am removing the mouse, okay, keeping the mouse, you can see from here to here. And then after, during the negative half, the lower diode D2 will work and you will get again the output from here to here. So your alternating current, which was having the positive halves and the negative halves, is converted into the direct current which has only the positive halves. In this way, the signal which is having positive half and then negative half and then positive half, then again negative half, is converted into this output form which has only the positive halves, and this particular circuit is called as a rectifier circuit, and the signal which has positive half and negative half is called as AC current, and the signal which has only the positive halves is considered as the DC current. Now we'll talk about the ICs, integrated circuits. You might have heard, if some instrument is not working at your home, you call some engineer to repair it. Then that person will always say, some IC is not working, I have to change it. So in short, we are talking that as IC, but it is electronically named as integrated circuit. It is electronically named as integrated circuits. So integrated circuits are like this. You have seen the size is bigger here. Nowadays, we have n number of smaller ICs, and the current flows in the PCB like this by the blue symbol. The flow of the signals are being shown here on the diagram. And this part, the middle part, is considered as an IC with different pins. This type of IC here, and the signal comes like this to that.